Why use getters and setters, accessors, in Java? Introduction. One of the most common concepts in object-oriented programming, OOP, is encapsulation. Encapsulation means protecting object data, controlling access to fields, hiding internal implementation details. In Java, encapsulation is usually achieved using private fields, getters, setters. A very common beginner question is, why use getters and setters instead of public fields? Example: private string name, get name, set name. This topic helps learners understand what getters and setters are, why encapsulation matters, benefits of accessors, validation logic, immutability, framework compatibility, best practices, common misconceptions. This is a foundational Java OOP topic. What are getters and setters? Getter, a method used to cap, read field value. Example: public string get name, return name. Setter, a method used to update field value. Example: public void set name, string name. This dot name equals name. Full example: public class user, private string name, public string get name, return name, public void set name, string name. This dot name equals name. Usage: user equals new user. User dot set name John. System dot out dot println user dot get name. Output: John. Why not use public fields? Example: public class user, public string name. Usage: user dot name equals John. This works, but has major problems. Problem 1. No validation. Example: user.name equals / or user.name equals null. Invalid values can be assigned freely. Validation with setters. Example: public void set name, string name. If name equals null or name dot is blank, throw new illegal argument exception, invalid name. This name equals name. Now object state is protected. Example concept setter. Validation. Safe object state. Problem 2. Loss of encapsulation. Public fields expose internal data directly. Example concept. External code direct field access. This tightly couples implementation to users. Encapsulation with private fields. Example: private string name. Now internal implementation is hidden. External code interacts through methods. Problem 3. No future flexibility. Suppose today, public string name. Later, you need logging, validation, formatting, synchronization. Changing public field to methods may break existing code. Getters and setters provide flexibility. You can later add logic safely. Example: public void set name, string name. System out println, updating name. This name equals name, without changing external API. Problem 4. Read-only fields. Sometimes fields should be readable but not writable. Example: ID, creation timestamp, calculated values. Getter without setter. Example: private int ID, public int get ID, return ID. No setter provided. Now field becomes read-only externally. Immutability. Important OOP concept. Immutable objects. Objects whose state cannot change. Example: private final string name, public string get name, return name. No setter exists. Very common in check, DTOs, records, multi-threading, enterprise systems. Framework compatibility. Many Java frameworks rely on getters, setters. Examples: Spring Boot, Spring Hibernate, Spring Jackson, Spring JSP, Spring JavaBeans, JavaBeans convention, standard naming pattern, type, example, getter, getName, setter, setName, Boolean, getter is active. Frameworks automatically detect these methods. Example: Jackson JSON serialization, public string getName. Jackson uses getters to create JSON without accessors. Comma. Serialization may fail. Example: Hibernate ORM. Hibernate often uses check getters setters to map database entities. Security and data protection. Setters allow key, restricting invalid updates, sanitizing input, preventing dangerous state. Example: public void set age int age. If age is greater than 0, throw new illegal argument exception. This.age equals age, computed getters. Getters can return calculated values. Example: public string get full name. Return first name plus last name. No actual field needed. Very common in enterprise applications. Common misconception. Some beginners think getters, setters are useless boilerplate, but they provide encapsulation, flexibility, maintainability, framework support. Modern Java and Lombok. Modern Java often reduces boilerplate using a getter, at, setter from Project Lombok. Example: getter, public class, user, private string name. Lombok automatically generates accessors. Java records. Modern Java records reduce accessor boilerplate. 2. Example: public record user, string name, int age, jot. Records automatically generate. Getters, constructor, equals, hash code. Common errors. 1. Making everything public. Example: public string password. Poor encapsulation and security risk. 2. Setters without validation. Example: set age -100. Invalid object state. 3. Exposing mutable collections. Wrong. Public list string get items. Return items. External code can modify internal list. Better. Return collections.unmodifiable list items. 4. Generating unnecessary setters. Not every field should be mutable. Example: IDs, timestamps, calculated fields. Best practices. Best practices include keep fields private, expose only necessary accessors, validate inside setters, use immutable objects when possible, avoid unnecessary setters. Example concept: controlled access means safer applications. Advantages of getters and setters: check encapsulation, check validation, check flexibility, check framework compatibility, check maintainability, check security. Limitations: more boilerplate code. Excessive setters may reduce immutability. Poorly designed accessors can expose internals. Concepts learned in this topic. Okay, encapsulation, getters and setters, private fields, validation logic, immutability, JavaBeans conventions, framework integration, object protection. Simple definition. Getter: a method used to read the value of a private field. Simple definition. Setter: a method used to safely modify the value of a private field. Final summary. Getters and setters are used to support encapsulation, validation, flexibility, framework compatibility, safe object design. Instead of public string name, Java commonly uses private string name with getName, setName. Key idea: getters and setters protect object state and provide controlled access to data. Once you understand encapsulation and accessors, your Java class design becomes much cleaner, safer, and more maintainable.